Hello students, good evening. Can you see the screen properly? Okay, so we were discussing about solution chapter. Yes, so we have completed the MCQ parts and fill in the blanks and some of the questions. Okay, so we will deal with the remaining part. Fine. So we had seen the 2 marks question. Yes. So we have seen the first three questions. Yeah. So now we'll start with the third one. Sorry, fourth one. Okay. So the fourth question is, what is the effect of temperature and pressure on the solubility of gas in liquid? Give reason. Okay. So what is the effect of temperature and pressure on the solubility of gas in liquid? Give reason. Fine. So what is the answer for this? Yes. So how the effect of temperature and pressure is on solubility of gas? How it affects? Yes. So first we'll see the effect of pressure. Okay, first we'll see the effect of pressure on the solubility of gas. So you know that at given temperature, okay, at given temperature, fine, the solubility of a gas in a liquid is directly proportional to pressure on the surface of liquid, which is Henry's law, right? So what will happen as we increase the pressure? So as you know, the partial pressure, okay? So the solubility of a gas in a liquid is directly proportional to the pressure on the surface of the liquid. Fine. So this is called as what? This is called as Henry's law. Okay, so when we remove this proportionality sign, so that is Kh into mole fraction. So as we increase the pressure, so as we increase the pressure on the surface of the water, what will happen to solubility of gas? So solubility of gas in water also increases. Okay, so this is the effect of pressure. Okay, so this is the effect of pressure. So at given temperature, what will happen to solubility of gas in liquid? It is directly proportional to the pressure on the surface of the water. Okay. So as the pressure increases, what will happen? The solubility of the gases in water also increases. So this is the, you have to write the answer. Okay. So this is the 2 marks question. So 1 mark for effect of pressure and next is for effect of temperature. So how is the effect of temperature on the solubility of gas? So as there is increase in temperature of the water, okay, what will happen? The solubility of the gas will decrease. Okay. So as you increase the temperature, because you're keeping the temperature constant. So as you increase the temperature, what will happen to the solubility of the gas? The solubility of the gas will decrease. Okay. So the kinetic energy also increases and the gases will escape from the liquid. So this is the effect of temperature and pressure on the solubility of gas. So these are the 2 points you need to write. Okay. So I think this is clear. Okay. So these are the 2 things which you need to write. So please see that whenever I'm telling the points, okay. So please note it down. Okay. Make sure you take a pen and a paper and make some important points. Okay. So if you write these important points in your answers, then only you can fetch the marks. Okay. So if you write unnecessary anything, it will not fetch you marks. Okay. So there should be proper words, proper key points should be included. So if the proper key points are included, then only you can fetch the marks. Okay. So next question, state Henry's law. Okay. Give the mathematical form. So this is the state Henry's law, give mathematical form. Yes, what is Henry's law? Yes. So according to Henry's law, what is Henry's law? As the temperature is kept constant, the amount of gas that is dissolved in liquid is directly proportional to its partial pressure of the liquid, right? So this is Henry's law. What is Henry's law? So as you keep temperature constant, okay, as you keep the temperature constant, the amount of gas that is dissolved in the liquid is directly proportional to its partial pressure. So how? So this is 1 mark. And for the mathematical expression, you will get another mark. So what is the mathematical expression? Partial pressure is directly proportional to mole fraction, chi. Okay, so when you remove this proportionality sign, you will introduce a proportionality constant, that is kh into psi. Okay, so this is your mathematical expression. So for mathematical expression, 1 mark, and for the law, 1 mark, right? So so like this. So for if you if you do, so for the law you have to write 1 mark, and for this mathematical expression you will get another mark. Is it understood? Yes. Okay, so we'll go for the next question. How kh is related to solubility and temperature? Okay, so just now we have seen this. We have seen in terms of the uh, theory part here. Okay, now we'll see mathematically how kh is related to solubility and temperature. Okay, so what is according to Henry's law, you know that partial pressure, okay, is directly proportional to its mole fraction, right? So now, yes, so when you remove this proportionality sign, what you will introduce? You will introduce the Henry's constant. What is Henry's constant? Henry's constant is kh into chi. Okay, so if I take this kh here is equals to pressure, partial pressure divided by chi. Okay, so if you keep pressure constant, okay, if you keep this pressure constant, so your Henry's constant, that is kh, is inversely proportional to its chi. Okay, that is higher the value of kh, lower will be its solubility. Okay, higher the value of kh, lower will be its solubility. So this is with respect to solubility. Okay, so as your kh value increases, what will happen to mole fraction? What will happen to solubility? Solubility will decrease. Okay, now you know that kh. So KH, you know that KH is directly proportional to this pressure. Okay, so as KH is directly proportional to pressure, so it is directly proportional to temperature. Okay, so KH, how it is related to temperature? It is directly proportional. Okay, so KH is directly proportional to temperature. Understood? Yes. So how KH is related to solubility? As the KH value increases, solubility decreases. Okay, as you know that kh is directly proportional to pressure. So as pressure increases, what will happen? So as you know, pressure is directly proportional to temperature. So as kh value increases, yes, so temperature also increases. It is directly proportional, and kh and solubility is inversely proportional. Okay, so these are the two things, okay, which you need to remember. So next question, states Rawls law. So these are some of the important questions which are asked only. Okay, so these are some of the questions which are asked. Okay, so based on the previous papers, so if you okay, if you see, so these are repeatedly asked questions. So you have to focus on these questions if you want to score good. So if you love physical chemistry, so there are three lessons in physical chemistry, right? One is your solution chapter, second is electrochemistry, and the third is chemical kinetics. So if you love physical chemistry, if you are good in mathematical part, okay, if you're good in solving problems and all, so you can fetch good marks in these part, okay. So you have to stress more on these questions, fine. So the next question is, states Rawls law of relative lowering of vapor pressure. Okay, the next question is what? States Rawls law of relative lowering of vapor pressure. So what is Rawls law? Yes, what is Rawls law? So the vapor pressure of the solvent over the solution is equal to the vapor pressure of pure solvent, okay, which is multiplied by its mole fraction in the solution. Okay, so this is your what this is your Rawls law of relative lowering of vapor pressure. Okay, Rawls law. So this is very important. Okay, Rawls law is asked question. So these are, so out of this three, okay, so this can be asked in MCQs or it can be in the part of 2 marks question. So any of this, define the molality, how it is depend on temperature, or molarity or mole fraction, how it is depend on temperature, either of one. Then Henry's constant, okay, and their effects. Okay, so these are important question. Then Rawls law. Next is differences between ideal and non-ideal solution. So this is a very, very, very important question. 100% sure question, right? So some questions are like this. If you see those questions, you will be sure, right? You know that this is a asked question. So that time what you have to do, you have to blindly write this answers. Okay, you have to blindly write the answers. Okay, so there should be no mistake. So these are scoring questions. So what are the two differences between ideal and non-ideal solutions? Yes. So what you have to do, the main thing first, you have to do 2 columns. Okay, do ideal solution, and in another column you write non-ideal solution. So you have like this, you have to do 2 columns. Okay, you have to do two columns first. Then what you have to do, so write the points. How you'll write the points? So what is ideal solution? Ideal solutions are those solutions which obeys Rawls law. Okay, which obeys Rawls law. Now, what is non-ideal solution? For this point only, you have to write for non-ideal solution. Yes. So what is non-ideal solution? Which do not obey Rawls law. Okay, which do not obey Raoult's law, okay, which do not obey Raoult's law. So if you write this correctly on the either side, you will get 1 mark. Okay, you will get 1 mark. So you got 1 mark. Now, second point is what? Delta H mix is equal to 0. Okay, delta that is change in enthalpy. Okay, after mixing is equal to 0. And here delta H mix, that is change in enthalpy after mixing, is not equal to 0. Okay, it is not equal to 0. Fine. So like this. Fine. So, so if you write this properly, so delta H mix, this all things should come. Okay. If there is any mistake, then it will be wrong. So you can take one more point if you want. So delta V mix. Okay. That is change in volume mixing after mixing is equal to 0. Here delta V mix is not equal to 0. Okay, so any 2 points will get you 2 marks. Okay, so correctly on either side it should be written. Fine. Next question, what is reverse osmosis and mention any one of its use? So this is also very important question. Okay, so what is reverse osmosis and mention any one of its use? So this is also a must asked question. Okay, so what is reverse osmosis? Yes, we have seen this in the in our MCQs part. So I'll just tell the definition. What is reverse osmosis? So if the external pressure, okay, when you put a external pressure which is greater than the osmotic pressure, okay, so when you put the external pressure which is greater than osmotic pressure, okay, on the solution side, then the solvent molecule, what will happen? They will flow from solution to solvent. Okay. So as you put the external pressure greater than the osmotic pressure on the solution side, okay, then what will happen? The solvent molecules will flow from solution to solvent through what? Through a semi-permeable membrane. Okay. And this is called as reverse osmosis. So that is reverse osmosis is what? You're putting an external pressure. Okay. And this external pressure is greater than the osmotic pressure. And where this pressure is applied? On the solution side. Okay. Now for this definition, 1 mark. And what is its application? Remember, desalination of seawater. Okay, desalination of seawater. So this is the use. Okay, desalination of seawater is the use of reverse osmosis. Okay, so in the sleep also, if anybody wakes you up and they ask you what is the use of reverse osmosis, you should be able to tell it is desalination of seawater. Okay, so this is very important. Fine. So we'll go for the next one. I hope you are getting it. Yes, if you have any doubts, you can leave your message in the chat box. Yes, okay. So next question is, what are azeotropes, and give an example. Okay, so what are azeotropes? Yes, what are azeotropes? So azeotropes are what? So they are the binary mixture. Okay, so they are the binary liquid mixture. Just a second. Okay, so binary liquid mixture, okay, which are having same composition. So having same composition in liquid and vapor phase, okay, and in vapor phase. And they boil at constant temperature, okay, and boil at constant temperature, and they are called as what? Azeotropes. Okay, remember what are azeotropes? They are the binary liquid mixtures which are having same composition in liquid and vapor phase. Okay, and these mixture they boil at constant temperature. Okay, so remember one example. Example is very important. Okay, 95.5% ethanol, 95.5% ethanol plus 4.5% water by volume. Okay. So this thing should be important. Okay. You have to write by volume. So 95.5% ethanol plus 4.5% water. Okay. 4.5% water by volume. Okay. So this is the example. Okay. So this is about azeotropes. Next is, what is minimum boiling azeotrope? Give an example. So what is minimum boiling azeotropes? Now what do you mean by minimum boiling azeotrope? So the solutions which show large positive deviation. Okay, remember this. The solutions which show large positive deviations from Raoult's law. From Raoult's law are called as what? At a specific conductance, okay, or at a specific composition, then it is called as what? It is called as minimum boiling azeotrope. Okay, so the same example can be given. So this same example can be given 95.5% ethanol plus 4.5% water by volume. So this is about minimum boiling azeotrope. Fine. Next is maximum boiling azeotrope. Now, what do you mean by maximum boiling azeotrope? Yes. So the solutions which show large negative deviation. Yes. So the solution which show large negative deviation from Raoult's law at specific composition. Okay. At specific composition is called as what? Maximum boiling azeotrope. Yes. So write down the example. So example, please note down the example. 68% HNO3 plus 32% water. Okay. By mass. By mass. Okay. So 68% HNO3 plus 32% water by mass. Okay. So what is maximum boiling azeotropes? So these are the solutions which show large negative deviation from Raoult's law at specific composition. Okay. I hope this is clear. Yes. Is it clear? What are azeotropes? What is minimum boiling azeotrope and what is maximum boiling azeotrope and the example? Is it clear? Yes. Is it clear? What are azeotropes? What are minimum boiling azeotrope and maximum boiling azeotrope? Yes. Okay, good. Okay, so we'll moving further. Fine. So next question. Aquatic animals are more comfortable in cold water than in warm water. Give reason. Yes. Why aquatic animals are more comfortable in water, cold water? Yes. If we take cold water bath, we'll get easily cold. Yes. And why the fish and the other aquatic animals, they stay comfortable in cold water? We can leave them in warm water also, no? But why they are more comfortable in cold water rather than warm water? What is the reason? Yes, because what is the reason? The reason is the solubility of oxygen in is more in cold water. Okay, so solubility of oxygen is more in cold water. Okay, remember this point. So if you write this proper reason, you will get 1 mark. So solubility of oxygen is more where it is more in this cold water. Okay. Next, name the law behind the dissolution of carbon dioxide in gas in soft drinks under pressure. Yes. Which law is applicable for dissolution of carbon dioxide in gas? Yes. What do you mean by dissolution of carbon dioxide? So when we put high pressure, when we so due to high partial pressure of carbon dioxide, what will happen? The amount of dissolved carbon dioxide is very high in soft drinks. You know that this carbon dioxide gas is compressed, right? It is compressed in the soft drinks, in aerated drinks. So after we remove the cap of the soft drink, what will happen? This the carbon dioxide gas will escape out, right? And what it will produce? It will produce effervescence. Okay. And what will happen? The external pressure will decrease. So how this is demonstrated? Which law is applicable? So it is due to Henry's law. Okay. So it is the applicative part of Henry's law. Okay. So when so what is done? The gas carbon dioxide gas is filled in the aerated drinks. Okay. So high pressure is applied. So when you open the gas, what will happen? When you open the cap, sorry. So excess of this carbon dioxide gas will escape out and it will produce more effervescence, right? You have seen the bubbles coming out, right? Why it will come out? Because more carbon dioxide gas will be filled in that. So this is due to Henry's law. So this is application of Henry's law. Okay. Next is soda water bottles are sealed under high pressure. Give reasons. So it's the same one. Okay. So why the water bottles are sealed under high pressure? Yes. Why? Why the soda water which is there? Okay, soda water will be there. Then what is done? The gas is what you say? The gas is passed. Okay, the gas is passed under very high pressure. Why? To increase why it is passed? To increase the solubility, to increase the solubility of a gas in liquid. Okay. So to increase the solubility of gas in liquid. Fine. So soda water bottles are sealed under high pressure. Why? What is the reason? To increase the solubility of a gas in liquid. Fine. So this is the okay. So this is the reason. Is it clear? So these are some of the applicative questions. Okay, so these are the applicative questions. I hope you are writing down the points. Yes, I hope you are writing down the points. It will be helpful for you. Now, okay, if you sit idly, now you will feel that you have understood it. But after some time, what will happen? the things which you have heard now, it will just escape. How it will escape? Like carbon dioxide gas, right? How the carbon dioxide gas will escape out, right? The same way your answers from your head will be escape, okay, after some time. So what is the best way? You have to note down the points, okay? So note down the key points so that it will be helpful. So when you just open the key points, you will just all the answers will be recalled. Fine. So with this, we have completed a 2 marks question. Now, as we know that for solution chapter, 1 mark, 2 questions are there. And yes, so 1 mark, 2 questions are there. 2 marks, 1 question is there, and 3 marks, 3 questions. So out of 3 questions for 3 marks, one will be a theoretical question. How it will be asked? Never 3 marks question is asked. Either 2 plus 1 will be asked. Okay. So again, 2 plus 1 question, one will be there, and other 2 questions of 3 marks will be of numericals. Okay. So now we'll see the numerical part. Fine. So now we'll look into the numerical part. So there are just a second. Okay. You can see this colligative property part. Yes, here. So on these formula. Okay. So on colligative properties, you will get the problems. Okay. So on colligative property, that is based on relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So we are going to see on these 4 formulas. Okay. Write down these formulas. So P1 naught minus P1 upon P1 naught is equals to W2 small w2 into M1 divided by M2 into W1. So this is the formula for relative lowering of vapor pressure. Then elevation in boiling point. So change in temperature, boiling point temperature is equals to Kb into M. Okay. So M2 molar mass of the solvent is calculated is equals to Kb into W2 into 1000 divided by delta Tb into W1. Okay. Next problem we are going to see on depression in freezing point. So the formula is delta Tf is equals to Kf into M. M2 is equals to Kf into small w2 into 1000 divided by delta Tf into W1. Then the last colligative property is osmotic pressure. Osmotic pressure is equals to, which is given as pi, which is equals to CRT. Okay, where M2 is equals to W2RT divided by pi V. Okay, so based on these particular formulas, we are going to see the problems. Is it okay? So on the colligative properties, fine. We are going to see the formulas. We are going to see the problems. So we'll start with this, okay, from on relative lowering of vapor pressure. So based on relative lowering of vapor pressure. So the question goes like this. 5.8 5.8 grams of a non-volatile solute was dissolved in 100 grams of carbon disulfide, that is CS2. The vapor pressure of the solution was found to be 190 mm of Hg. Okay, calculate the molar mass of the solute. Given the vapor pressure of a pure CS2 is 195 mm of Hg, the molar mass of CS2 is given as 76 gram per mole. Okay. So what is given? The solvent, here a non-volatile solute is taken. Okay. Non-volatile solute whose weight. So what all is given? I'll write it down here. So first thing, what you have to do? You have to write down the things. Okay. What all is given here? So the solute. So what is given? The weight of the non-volatile solute is given, which is given as W2. Okay. So W2 is equals to 5.8 grams. Fine. Which was dissolved in 100 grams of carbon disulfide. So this is what? It is a solvent. So carbon disulfide is a solvent. So solute is dissolved in. So this is W1. So the weight of the solvent is 100 grams. Fine. So the vapor pressure of the solution was found to be 190 mm of Hg. So pressure, partial vapor pressure, that is vapor pressure of the solution is given as P1. Okay, we'll take it as P1. So it will be 190 mm of Hg. Fine. Then calculate the molar mass of the solute. So it is given as M2. So molar mass of the solute is to be found out. Fine. The molar mass of the solute is to be found out. Then what is given? Given the vapor pressure of a pure CS2 is. So vapor pressure of pure. So how do you write the pure vapor pressure? It is P naught 1. Okay. So P naught 1 is given as 195 mm of Hg. Fine. So this is the given things, and molar mass of CS2 is given. So molar mass of CS2 is given as 76 gram per mole. Now what is the formula? Yes, we have seen the relative lowering of vapor pressure. The formula is like this. Okay. P naught 1 minus P1, P naught 1 equals to W2 into M1 divided by M2 into W1, small W1. Okay. Yes. Put down the things. What all is given? P1, P1 naught is 195 minus P1 is 190 divided by what is P1 naught is 195 equals to what is W2 is 5.8 into what is M1 is 76 divided by what is M2. M2 we don't know. We'll keep it as this. And what is W1 is 100. So what is the unknown thing is M2. So we'll transfer this M2 this side. Yes. So 195 minus 90 divided by 185. Okay. So this will be 195 minus 190. It will be 190. 5 divided by 190. Okay, so 5 divided by 195. So when you transfer, this will becomes 5.8 into 76 into 195. So this will become reverse. Okay, and here will be 100 into 5. Yes, see what answer you are getting. Yes, see what answer you are getting. Yes, what is the answer? All I've got. Try solving this. Yes. What is answer you have got? Just check. Mm, Oppo. Yes, Oppo. You can just edit your names. Okay. The answer is right. 171. Sanjeevni has also answered it right. It is 171.91 gram per mole. Okay. Unit is very important. Now here how the marks are given. Okay. 1 mark is for your correct what your formula. So 1 mark is for formula. 3 marks, right? 3 marks problem. 1 mark is for the substitution, correct substitution. 1 mark, and 1 mark is for your answer with the proper unit. Okay, like this. So 3 marks for 3 steps. 1 mark. So if the formula is only wrong, will you get the further marks? No. So first write the formula correct. Okay, so formula 1 mark, substitution 1 mark, and answer with the correct unit 1. Okay. So this was a problem based on relative lowering of vapor pressure. I hope this is clear. Yes. And I hope you are writing down the things. Yes. Later. So if you do not write, like the solvent will, how the solvent will be evaporating. Okay, so like that, your answers also will get volatile. Okay, so write down the things. Got it? So we'll go for the next question. Next question. 12.6 grams of a non-volatile electrolyte is dissolved in 75 grams of water. The freezing point of the solution is 271.9 Kelvin. If molar depression constant is 1.86 Kelvin kg per mole, calculate the molar mass of solute. So freezing point of pure water is 273.15 Kelvin. So this is based on the freezing point. Okay, depression in freezing point. So this problem is based on what? Depression in freezing point. So what are the things are given? Yes, what all things are given here? So what is the so what all is given? We'll write it down first. Yes. So given. So first is W2. So the weight of the solute is given. Okay, that is 12.6 grams. Okay, what it is? 12.6 grams. Then next is what? Solvent weight is given. It is 75 grams of water. The freezing point of the solution. So the freezing point is given. Okay, freezing point of water is given as delta TF. Okay, so that is TF naught is equals to 270. Sorry, TF is given, not. Okay, so the freezing point is given as TF. So TF is given as 271.9 Kelvin. Okay. Then if the molar depression constant, so how the molar depression constant is given as Kf. So Kf is the molar depression constant. It is 1.86 Kelvin kg per mole. Okay. Calculate the molar mass of solute. So what is the molar mass of solute? So molar mass of solute is M2. We have to calculate. Then the freezing point of pure water is given. That is delta, T naught F. Okay, T naught F is given as, what is given as T naught F? 273.15 Kelvin. Okay. So these are the things which are given. Now, based on this, so we have the formula for depression on freezing point. First, we have to find the change. Okay, the difference in the freezing point, okay, which is given as delta TF. T is equals to TF naught minus TF. Okay. So what is TF naught? It is 273.15 minus 271.9. So yes, what will be the answer? This comes to 1.21 Kelvin. Okay. Next, what is the formula? The formula to find the this molar mass of solute in terms of depression on freezing point is given as M2 is equals to Kf into small w2 into 1000 divided by delta Tf into W1. Okay. So what is Kf value? Kf is 1.86. What is W2? W2 is 12.6 into 1000 divided by what is delta TF? It is 1.21 into what is W1 is 75. Yes. Solve and see what is the answer. The answer should be in gram mole. Okay, the answer should be in gram mole. Yes. Okay. Ma'am, 1.25. Just a second. I take 273.15. Okay, if I take, okay, take it as 1.255, but it will not clear more this. Okay, 1.86 into 12.6 into 1000 divided by 1.25 into 75. Yes, see what will be the answer? Yes, others, what is the answer you're getting? Try to answer. Yes, what is the answer? Others, only one student is answering. What about others? Yes. Yes. Good. Gayatri, Sanjeevni, Priyanka. Yes, good. Okay. So the answer is 249.98 gram per mole. Okay. So this is the answer. Good. Okay. So like this. So like this, you have to, so again, 1 mark for the formula, 1 mark for the substitution, 1 mark for the correct answer with the unit. Okay. So we'll go for the next question. The boiling point of benzene is 353 Kelvin when 1.80 grams of a non-volatile solute was dissolved in 90 grams of benzene. The boiling point raised to 354.11 Kelvin. Calculate the molar mass of the solute. So, Kb for the benzene is given as 253 Kelvin kg per mole. Okay. Yes. So, what all things are given? We'll write it down. Yes. So, given. Okay. So, boiling point of a benzene is given. So, boiling point is given as Tb is given as 350 53.23 Kelvin. Okay. And weight of the solute is given. Weight of the solute is W2, which is 1.80 grams. And weight of the solvent is given as 90 grams. Okay. Of benzene is the solute. The boiling point was raised to TB is 354.11 Kelvin. You have to calculate the molar mass of the solute. Okay. Then Kb is given is 2.53 Kelvin. Okay, now which is the formula? First, see the change in uh, the boiling point. Okay, that is a raise in boiling point is given as delta Tb is equals to Tb minus T naught B, which is 354.11 minus 353.23. What will come? Just see what we'll get. 354.11 minus 353.23. It comes to 0.88. Yes, everybody got? Yes, good. So 0.88 Kelvin. Okay. Now substitute in the formula. So to find the molar mass of the solute, M2 is equals to Kb into W2, small w2 into 1000 divided by delta Tb into W1. So what is Kb? It is 2.53. What is W2? W2 is 1.80 into 1000 divided by what is delta TB? Delta TB is 0.88 into W1 is 90 grams. Okay, just see what answer you're getting now. 2.53 into 1.80 into 1000 0.88 into 90. 79. Yes, what answer you're getting? The answer should be in gram per mole. Okay. The answer should be in gram per mole because we are finding the molar mass. Yes. Yes, good. Vedavati, Ilsa, and Priyanka. Good. Okay. Good. Yes. Yes, good. Prakash. Yes. Sanjeevni. Yes, good. Okay. The answer is right. So it is 57.5 gram per mole. So again, how the marks are given? 1 mark for the correct formula, 1 mark for the substitution, and 1 mark for the answer with the correct units. Okay. I hope the problems are clear. Yes. Okay. So if you do not write the unit, straight away 1 mark will go. Whether your answer is right also, but still if you do not write the unit, 1 mark will go. Okay. So next question. The 300 centimeter cube of an aqueous solution of a protein contains 2.12 gram of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 3.89 into 10 raised to minus 3 bar. Calculate the molar mass of the protein. Okay. R is equals to 0.0823 L bar per mole per Kelvin. Okay, so what all things are given? So you know that osmotic pressure pi is equals to CRT. Okay, so which is the formula which we are going to use? We are going to use for finding the molecular mass. How is concentration given as? Concentration is given as number of moles, okay, divided by the molecular mass into RT. Okay. Okay. So this is the formula which we are going to use. First, we'll write the things which are given. Okay. So 300 centimeter cube. So volume is given as 300 centimeter cube. So we have to convert it into liters. If you convert it into liters, because it is 0.3 liters. Okay. Then the weight of the solute is given as W2 is 2.12 grams. The osmotic pressure, yes, osmotic pressure is given as pi, is 3.89 into 10 raised to minus 3 bar. Okay. Molar mass, yes, molar mass of the protein is given. R is given 0.0823. Okay. And temperature is also given here. So temperature is 300 Kelvin. Now, what all things are to be added here? Just see M2 is equals to WT is what? 2.12. What is R? 0.0823. Temperature is 300 Kelvin divided by what is pi? 3.89 into 10 raised to minus 3 into volume is 0.3. Yes. Now see what is the answer you are getting. Again, the answer should be in gram per mole. Yes. Yes. What is the answer? Yes. Yes, it is 44.85 into 10 raised to 3 gram per mole. Yes, good. Okay. Yes, gram per mole. Yes. Remember the unit. Remember, unit is very important. As I said, so 1 mark for the formula, 1 mark for the correct substitution, and 1 mark for the right answer with the correct unit. Okay. So yes, 44.852. Yes, into 10 raised to 3 gram per mole. Good, good. Yes, Vedavati, Elsa, Priyanka, then Prakash, Vishal. Yes, good. Okay. So, these were some of the problems, okay, based on solution chapter. So we have completed the chapter on solutions. So these are the things which we have discussed regarding the solution chapter. So we have seen the different methods of expressing the concentration of the solutions in terms of molality and mole fractions. So we have seen the definitions of molality and mole fractions. We have seen the units. Okay. So just take a look at this chart. So this is very important. So uh, this will completely freshen up all your whatever we have studied. Yes, to brush up the things. So remember, so the mathematical expressions of these concentration terms in terms of molality, and mole fraction. Remember, molality and mole fractions, they are independent of temperature, but molarity, it is inversely proportional to temperature. As temperature increases, molarity will decrease. Okay. What is Henry's law? Partial vapor pressure. Yes. Of a given liquid is directly proportional to its mole fraction. So it is P is equals to KH into chi. That is, KH is inversely proportional to solubility. As solubility increases, KH value will decrease. And you know that KH is directly proportional to temperature. As temperature increases, KH value also increases. Then we have seen the classification of liquid solution. What are ideal solution? Ideal solutions are those solutions which obeys Raoult's law. Non-ideal solutions are those which do not obey Raoult's law. So the example for ideal solution is benzene and toluene and N-hexane and N-heptane. Okay, so these are the uh, hydrocarbons. Okay, the alkanes. So benzene and toluene. So the hydrocarbons. Then N-hexane and N-heptane. The non-ideal solutions are those which do not obey Raoult's law. So there are two types again: positive deviation and negative deviation. Remember the examples of positive deviation: ethanol and cyclohexane, acetone and ethanol. Okay, remember the examples, very important. Negative deviation: water and nitric acid, acetone and chloroform. Then we have seen what are colligative properties. Okay. Colligative properties are what are colligative properties? Yes. So colligative property depends on what? It depends on the number of solute particles. Okay, and not on the nature of the solute particles. Fine. Then these were the four properties which we have studied. We have seen the formulas, right? Then Van't Hoff factor, which is given as normal molar mass, okay, which is Van't Hoff factor is expressed as I, which is given as normal molar mass divided by abnormal molar mass. Okay, Van't Hoff factor will account for what? It will account for extent or of association or dissociation of a solute. Okay. For solute which do not undergo association or dissociation, Van't Hoff factor will be equal to 1. For solute undergoing association, Van't Hoff factor is less than 1. And for solute undergoing dissociation, Van't Hoff factor is greater than 1. Okay. Then colligative properties for solute undergoing association or dissociation. Okay. So this is the particular formula. It is pi is equals to I CRT. It depends on the Van't Hoff factor I. Okay. So these are the important things which are to be studied in this particular chapter called solutions. Yes. Any doubts in this particular chapter? Yes. YouTube students, any doubts? Okay, fine. So, coming to end, we have finished this particular chapter. Okay. So, next chapter which we are going to discuss is So today we'll just see the definition. Okay. Then we can continue this particular chapter in the next class. So the next chapter which we are going to take is electrochemistry. Yes. So can anyone tell me what is electrochemistry? Yes. Did you study about electrochemistry? So what are the total marks which you are fetching for this chapter is 14 marks. Okay. So electrochemistry chapter is totally for 14 marks. So out of 14 marks, how the 14 marks are distributed? So 1 marks, 2 questions are asked. Okay. And these 2 questions both are MCQ questions. Fine. Then 3 marks, 4 questions are asked. Out of these 4 questions, 2 are theory based questions and 2 are numericals. Okay. So 1 mark, 2 questions, and 3 marks, 4 questions. So out of 4 questions, 2 are numericals and 2 are theory-based questions. Okay. Now coming for the point, what is electrochemistry? Yes, will tell me what is electrochemistry? Yes, what is electrochemistry? Can anyone tell me? What is electrochemistry? Yes. So it is a branch of chemistry, right? Electrochemistry is a branch of chemistry which deals with interconversion of chemical energy into electrical energy. Okay. So what is happening here in electrochemistry? There is a interconversion. Okay. Interconversion means what? One chemical energy. Okay. Your chemical energy is converted into electrical energy. Okay. So electrochemistry. So what is happening? Your chemical energy is converted into electrical energy. So there is a interconversion which is happening. So this is a branch of chemistry wherein there is a interconversion of chemical energy into electrical energy. Okay. And these the chemical reactions which are involved are called as redox reaction. Yes, what do you mean by redox reactions? You have studied in first year. So the chemical reactions which are involved here are called as redox reaction. What are these redox reactions? Yes, redox reaction means what? Yes, simultaneously oxidation and reduction takes place. Okay. So redox reactions are those reactions where simultaneously reduction and oxidation takes place. Okay. So we'll see some 2 definitions and then we'll stop. Okay. So here we are going to study in this about conductors, insulators, semiconductors. So these are some of the things which are discussed in this particular chapter. But for our importance are conductors. Okay. So what do you mean by conductors? Yes, what do you mean by conductors? So the substances which allow the passage of electricity. Okay. So substances which allow the passage of electricity through them. So the electric current can pass through them. Okay, such substances they are called as conductors. So which are the substances? What will be the example for conductors? For example, your metals, okay, alloys, graphite. What do you mean by graphite? Pencil. In pencil, the lead which is there, it is nothing but your graphite. Okay, it is a allotrope of carbon. Fine. So metals, alloys, graphite. Okay, then some of the polymers, then some of the electrolytes. So these are some of the examples of conductors. Okay. So what are conductors? So these are the substances which allow the passage of electricity. Okay. So electricity can be passed to these substances. So they are called as conductors. Okay. And now some substances which cannot pass electricity, what they are called then? They are called as insulators. Okay. So some substances they cannot, they do not allow the passage of electric current through them. Okay, so such substances are called as what? They are called as insulators, or they are called as non-conductors. So which are the substances? Like rubber, okay, plastic, then ceramic, glass, wood. Okay, so these are some of the examples of your insulators. Now, for us, the most important thing is conductors. Okay, so we are going to study two types of conductors here. So which are the two types of conductors? First is metallic conductor and the second is electrolytic conductor. Okay, so what do you mean by metallic conductors? Yes, what do you mean by metallic conductors? So metallic conductors, what they do, they allow the passage of electricity, okay, through them, but without undergoing any chemical change. So without undergoing any chemical change, it will allow the passage of electric current. Okay, so electricity can be passed. So electricity can be passed through these metallic substances. Okay, so here what is the conduction is possible due to what? So the conduction is due to it is due to the movement of electrons. Okay, remember in your metallic conductance, the conductivity is due to electrons. Okay, why the conductivity is due to electrons? Fine. And electrolytic conductance, what do you mean by electrolytic conductance? Electrolytic conductance are those substances which allow the passage of electric current, but either in their molten state or in their aqueous solution state. Okay, so they allow the passage of electricity, but either they should be in your molten state or it should be in aqueous state. Okay, and here the conduction is due to what? It is due to ions. Remember these very important conductors, two types. One is metallic conductors, another is electrolytic conductors. Metallic conductors means what? The conductivity is due to electrons. Okay, the electricity is passed through these substances but without undergoing any chemical change. Electrolytic conductance means what? Electrolytic conductance, you allow the passage of electricity, but either it should be in molten state or it should be in aqueous solution state. Okay, and here the conductivity will be due to the ions. Fine. So this is about conductors. So the remaining part about the conductance. Okay, what are the unit, or what are the types of cell, batteries, and all things we shall be discussing in the next class. Okay, so next class will be continuing with the electrochemistry. Okay, I hope the chapter solution is clear. Yes, so we'll be continuing with the electrochemistry in the next class. Okay, so if you have any doubts regarding today's session, you can ask me. So I hope all your doubts and all your queries are clear. Yes, I hope you have understood the things. So please go through the things which you have been told. So next class will be continuing with the electrochemistry chapter. Okay. So I'll end the session here. So we'll meet in the next class. So thank you, dear students. Have a good day.